All right, guys. So last week we talked about this refrigerator. We talked about it had a leak and we weren't able to find the leak. We tried soap, we tried the electronic leak detector, and then last week we added some of the fluorescent dye, and you'd have to watch the first video to see that. And so what we were doing is letting that dye run. We had the refrigerator running with a full charge on it to see if the Freon would leak out. So this is an infrared or like a black light. It's used to determine where the leak is. So what you're supposed to do after you put that dye in, it's a little bit hard. You need like your inspection mirror to get the back side, but you got to go around the pipe anywhere you can. And then if you could see here on the floor, can you see the floor here? Can you see how this fluorescent is reflecting on the floor here, where we had spilled some last week on the floor? That's what we're looking for on this system. And we've already checked it before the video started. We weren't able to determine where this leak is, even with the dye. The leak itself could be internal in the inside the refrigerator. So go ahead and pause the video for a second. Okay, so we notice that the pressures are still going down. When it's off, it's supposed to be somewhere over here about 60 psi, and we're already at 25. So we're still losing pressure. We just don't know where the pressure is. And just because we put the dye in, remember, we talked about part of the refrigerant line, the condenser loop or the hot gas loop is running through the cabinet of the refrigerator. And even if that was leaking, we can't see it because it's inside the insulation of the fridge. So we know there's a leak. We haven't been able to physically find it. So what do you guys think the next thing to do to try to correct this or to fix the problem? Well, we did. We put nitrogen in there and we soap tested, because nitrogen you can't check with electronic leak detector, and that didn't determine anything. That was last week. We did nitrogen with soap tests to see if pressure would leak out. And the purpose of nitrogen, again, is just so that the whole system is pressurized and the compressor don't need to be running. And that didn't work. Then we went to electronic leak detector. We put nitrogen with a little bit of Freon, and it wasn't detecting anything. So that's why we went to the fluorescent dye. So what we're going to do is we're going to start isolating components. And what that means is we have the condenser in the back, and inside we have the evaporator, the high side and the low side. The other part of the high side is the hot gas loop. It comes out here and it goes in over here. So what we're going to do, and I'm not going to catch this on video, I'll show it after he does all the add-ons, is we're going to separate it into 3 separate compartments. The condenser, which this line coming off the compressor, we're going to take this line off and we're going to add an access valve to it. And this is coming out the condenser. So we're going to separate this line right here, and we're going to put valves on both these lines, and we're going to pressurize just the condenser. So if the leak is the condenser, we'd be able to see after we put 100 psi of nitrogen in there, if it leaks out, we know that the condenser is leaking. If we put 100 psi on the condenser and it doesn't leak out, then we know our condenser is not a problem. The same thing with the evaporator or the heat exchanger. The hot gas loop. We're going to put a valve on the hot gas loop here, and we're going to remove the dryer filter and put another valve on the other side of the hot gas loop, and we're going to pressurize that. The last thing that we're going to check is the evaporator. The evaporator is the suction line, and that's this line coming here inside the compressor, and going in is the capillary tube here. So we go in and out the evaporator through that heat exchanger. So we're going to separate 3 parts of this refrigerant system and pressurize each one individually. And we're going to put a set of gauges on each one of those lines. If we put a set of gauges on the high side, the low side, and the hot gas loop, only one of them should leak. And that's where our problem is. Once we've determined what part is leaking, then we'll discuss how do we go about and how do we fix that. So do you guys understand this process that we're going to do? Any questions? No? Okay, stop the video. Watch the solder on the pipe start to liquefy. Wait a few seconds. Heat it up at the joint. And there was some pressure still inside the system. It didn't totally get out. And that's all you have to do. Now, if I pulled it out too soon, this line would have broke and a piece of that pipe would have stuck in the compressor. Okay? I see a lot of people are rushing when they take it out, that they get it hot, they see that liquefy, and they start pulling on it, and it doesn't come out, so they think it's just stuck in there, and they pull on it even harder, and then the pipe itself breaks. One piece stays inside. So when you're heating, you want to heat both pipes, the compressor and the other line, heat it up, but then once it liquefies, you want to move your heat towards the bigger pipe or the outside pipe so that when it's inside the pipe that you're melting the solder where those two pipes are. Okay? So I've disconnected this one. We have one down here we need to disconnect. We have the suction line we need to disconnect. And we need to move the dryer filter and take the capillary tube off of there. We're just going to cut the cap tube. I'll get cap tubes cutters for that. So I want you to come here, and right here, where this line is, there should be a place where it's brazed together. It should be right there my finger is. So I want you to figure out where are you going to put your heat that you're not going to melt wires, melt the customer's floor. You don't want to blow it right against their cabinet. You might want to just like come in from this side and then pull it that way. So go ahead and see if you can go ahead and do that while I get the cap tube cutter. On video. When we do this, you don't want to be straight down like perpendicular to the pipe and just cut straight down like that. What you want to do is you actually want to cut it at an angle when you cut it, and then you want to double check your opening to make sure your opening's not restricted. If your opening's restricted, you have to cut it again. Okay? But don't cut it straight down, because when you cut it straight down, it tends to compress or crush the capillary tube, and we don't want to damage the capillary tube. Okay? So down here where the capillary tube meets the dryer filter, we're just going to cut about an inch away from the dryer filter. We're just going to cut this capillary tube. Now this capillary tube goes into the evaporator, and so all we're going to need is this suction line and that capillary tube to isolate the low side. Again, once we isolate it, we'll go over it and identify which component is which. Then we're going to pressurize all three. I want to come back here in the afternoon or later this evening and take a look at the pressures to see which one of the three drop pressure. Because now, by separating each compartment, the high side condenser, the hot gas loop, or the evaporator, if it's leaking from one side, now I know where my leak is at. I may not know exactly the hole or whatever, but I know it's maybe my evaporator or maybe my condenser. And then I can have a little bit better idea of trying to find out where that problem is. Okay? So go ahead and let's remove these lines. You can stop it. Okay, so we got 6 valves. Since we got 3 separate sections we're going to isolate from each other, we're going to put valves on there. So this is the condenser, one side of the condenser, this one right here, and I can bend it carefully. So these two here are going to be the in and the out of the condenser. So we're going to put a valve on each one of these pipes. We're going to have to sand them, we're going to have to flux them, we're going to have to braze them on and everything else and clean them up. Now this pipe went to another one in here, so we need a valve to go in here. And the other side of that pipe is the one coming out here. So we're going to have to put a valve here. Now the last one are these 2 lines right here. This is our capillary tube here and our suction line. So we got 2 for that. We got 2 for our hot gas. And we got 2 for our condenser. So once we've soldered these on, or brazed them on if you want to call it by the correct term, once we brazed all of these on, then we're going to pressurize the system with nitrogen and try to get each one of them to 100 psi. By doing that, We could use one set of gauges for how many sections of the system?
This 3 sections, right?
Well, come with the camera here just for a second to the board. Let me show you something. Okay, guys, look at this. So here's our refrigerator, right? Compressor was right here. Compressor discharge line went into the condenser and came back down here to go into the box. We've separated these two lines, and I'm going to use a different color for a valve here and a valve here. That's going to isolate the condenser. That's one of the 3 sections we're going to isolate. I'll use a different color. Coming off of this line runs inside the wall, goes around the freezer opening like this, and comes back down here where the dryer filter was. So that red line is the hot gas loop. That is the hardest hardest line to find the leak in. If I pressurize it and we lose pressure on that, we know that's leaking. But remember, I said in last week's lecture that you can't repair that. That's internal. The only thing we could do is run that heater kit through the line to prevent it from sweating, which is about an almost $200 kit. Now, I did put that kit on the last video. Okay, so that was one section. So I need 2 valves, and I'll use a different color, one here and one here. So remember, I said 6 valves, 2 on a condenser. I'll put that condenser here. This one here is the hot gas loop. And the last thing in will be the evaporator, and I'll use this color here, that you have an evaporator running inside the box, and it has 2 lines here that run together. We call that the heat exchanger. This is the suction and capillary tube. So we got 2 lines here. So we got the condenser, the hot gas loop, and the evaporator. Those are the 3 sections that we took this whole sealed system and we separated or isolated each one of those compartments. We're going to pressurize all of them to 100 psi and then come back in a little bit to see which side drops, because that's going to identify to us where our problem is, whether it's the evaporator or the condenser or what. So I need 2 more valves on here, and I'll use a different color. I'll use this green. So we're going to put 2 valves here. So we have 1, 2, 3, 4, 5, 6 valves. Now the question I asked was, how many refrigerant gauge sets do we need to make this test? 2? And how would we do it with just 2?
1 in low, 1 in high.
Okay, so let me just get a picture of refrigerant gauges. If I can find a decent one. Okay, here's one. So if we wanted to do them all simultaneously, you are right. You originally said 3 hoses or 3 gauges, but we only need 2. This one here, we have a low side and a high side in our gauge. Now, let's just say the condenser. These 2 right here are condenser in and out. Coming in with the black line and coming back out here. We're going to put valves on both sides only so we can pressurize that. So if we put pressure in one side, the valve on the other side will keep the pressure coming out. I do not need to put one hose on each one of those valves. I only need to do one side of that unit. So I'm just going to take one hose, and I'll use this here. I'm going to take this one hose, and I'll connect it to one valve. It's going to pressurize the whole system, and the valve here is just going to keep it from leaking out. And I'm just going to put this to 100 psi. Now, if I want to do the hot gas loop, which is this red one, I'm just going to go over here and run a hose on the high side to 100 psi. Now I just pressurize the hot gas loop. And remember, there's a valve here. I don't need to connect to both valves. I just need the valve there so that it'll hold the pressure when I put it in the system. Okay? So then I'll need one more of these gauges, because I ran out of hoses now. Make it a little bit smaller. So then I got another set of gauges. Now I only need one of those gauges themselves on the manifold. I don't need both. And then I'm going to run another hose from here to the evaporator. So I got one hose on the hot gas, one hose on the low side of the system, and one hose on the condenser. So the next step that we're going to do is we're going to solder 6 valves into the system. Then we're going to attach 2 sets of gauges. And with this one hose right here, hook it up to nitrogen, I can pressurize both of these sides of the system at one time. Once it's at 100, I just close them both. I'll put a piece of tape across it and mark where the needle is so I can come back later and see if it has dropped from my pressures, and we'll do that after that. So we got 1, 2, 3 gauges that we're going to connect to the system, and then once it's done, we'll catch that on video and show you guys the setup, and then we're going to mark them all, and then we'll come back at the end of class and see if they dropped. Any questions on this? Yes?
Just to clarify, there's 6 valves using 3 gauges, but because say two valves are attached to, say, the hot cold loop, you only need 1 gauge for that.
Well, here a little bit clarify. If I took those 3 systems, okay, I have, let's just say, here's my evaporator. Okay, one side's a suction line, and the other one's a capillary tube, and they're coming down here. Okay, so I'm going to put a valve here on the end and a valve on the end so I can connect my hoses. I'm going to connect a hose to one of them. When I pressurize, it's going to come all the way back to here. As long as I don't put anything on the valve, it's going to hold the pressure back. So I only need one hose.
Because the other valve is closed.
Yeah, the other valve, the only way the valve would leak is if the core inside was bad or something. But remember, you have to depress the core like a bicycle or car tire to get pressure in and out. So then we're going to do the hot gas loop, which was in red. Again, I'm not following all the colors, but we take the hot gas loop, and we got that hot gas loop that comes up and around and come back, and we got 2 valves on the end here. And with the 2 valves like this, we're going to hook up only one hose pressurizing this system. And then we got the condenser, which has a line in and a line out. And we're going to hook up 2 valves. And we're only going to hook up one hose here, and one hose there. So we've taken this whole system and separated it into 3 compartments. Only one of them is probably going to drop in pressure unless we have multiple leaks on the high side, the low side, and everything else. But as long as our braze joints are good, we're going to isolate them and then determine which part has failed, and then how should we go about fixing that side. Okay? All right, so go ahead and stop. I hope that this is still green and should still be recording. Okay, guys, so let's see, are those gauges in the camera? Can you see them in the lens? Okay.
I'll get it.
So why do we have the 2 gauges connected together? Well, no, they're not. But you have the wrong end connected to the gauge because this is the core depressor, and you don't have the core depressor on here, so you got
Okay.
the wrong end.
All right. So wrong.
So screw that on and put it to here.
This to here and the other two.
Need to. Well, we can't do this with the yellow. The yellow can't go on here.
Okay.
So no, don't connect it to the gauges. Take the red and yellow off of there. No, the back ones. This one is backwards from that one. Make sure they're all tight. You take the yellow one off too.
Both sides.
No, just the back. I'll edit this garbage off of the video. Just let it run. So let's break this down so we can see what's going on here. The first set of gauges on your left is this one here with two hoses on it. And the yellow hose, the center hose of your gauge, is always the one that we call the process hose. It's the one that we're going to connect to our vacuum pump, connect to our recovery machine, connect to the Freon tank to charge it. This is our service hose. And we're going to go ahead and put nitrogen inside the system. So we're going to connect this to the nitrogen tank to charge it with nitrogen. So if we look, we're coming in the yellow, out the blue, and we're going into this, which is the hot gas loop of the refrigerator. The other side is over here. Right here we have a valve on it. Now the cores are put on. I'm just going to go ahead and cap that end off because we're not going to use that. We're just using that to seal off the other end of that system or that pipe. Okay, so the next one is this red hose coming off of this gauge here, and this one's bent and no good. So I'm going to take this red one off of here because that one's damaged. And I'm going to move it over to this one here because this red one is still good. So if I put 100 psi nitrogen in here, it'll go out the blue one and do my hot gas loop. But I can also open up this one and do the red one, which is coming over here to, what is this line here, guys?
That's the capillary thing, right? Yeah, that's the capillary.
This is the capillary. What is this one? Suction line. Together it's called the heat exchanger, but these two lines are connected together. So when I put nitrogen here, that nitrogen is going to come all the way out to here, so I'm going to cap off my capillary tube. All right, so when I put nitrogen there, I've now pressurized this system. So these two gauges are going to do my suction line and my hot gas loop. This one gauge here is going to my condenser and coming out the other side, so we're just going to cap this off. So now we have three separate systems. And this yellow hose is going to be what we're going to put nitrogen in for the condenser. So bring that tank and connect this here, and we're going to put this to 100 psi. And then we're also going to do the yellow hose here and put both of these to 100 psi and then close these gauges as we charge it. Then I'll show you how we're going to mark it off, and then we're going to come back a little bit later and see if any of them drop so we can determine what part of this system is leaking. Now this is an excess, but this is what you'd have to do on any system if you've tried soap testing, electronic leak detector, and then we went as far as putting the dye in there and could not find the leak. It's probably the hot gas loop, but right now by separating those three parts, we're going to know exactly which one of those parts are causing our leak. So go ahead and put nitrogen here. Again, we adjust it with the regulator here. So come on this side and do this. Leave this gauge closed, but you're going to open and close this to meter the refrigerant to a 100 psi on the gauge.
I still need to open it up and regulate it.
Yes, you're going to have to first set up the regulator. Now we're going to let the regulator be higher than 100. Just leave it like that. Wait, that shouldn't be doing that. That should be tight. It was tightening up on you, but it wasn't all the way tight.
Another line.
Oh, this gauge is open. Okay, so this is at almost 200, which is okay. So now you're going to open and close this and try to stop at about 100. If it's a little bit over, it's okay. But we really don't want to be more than that 100 because too much more, the evaporator is aluminum. And this is the condenser, but if we do the aluminum over 100, we could damage it, which is the evaporator.
Jump straight up.
Okay. So we can let a little pressure off. Okay, so we can, what you do is you just crack it and close it. You see that? If I crack it and close it,
Yes.
I can meter the refrigerant, or in this case, nitrogen. And it's gonna fit. Why is it filling so fast? Why is it going so fast? I mean, like we do a regular refrigerator, it takes a minute to get everything to pressure. Because we're just doing the condenser. It's not much, it's not the whole system, so it's filling up just this condenser really fast. So I'm gonna put this to 100, or just past it. I'll take a little piece of tape, put it on the glass here. Now, Brandon will tell you that, you know, he likes the electronic because with the electronic, I could pressurize it to 100, and if it was leaking, you'd see a digital number, 100, 99, 98, and so forth. But that's digital. If you don't have the access to digital and you've got an analog one like this, we're just going to go ahead and do this, and then we'll just take and look at the needle and put a line on the tape like this, and I can walk away and come back an hour later and know if it has moved. Okay, so I want you to go ahead and just turn the tank off, disconnect the yellow hose, connect the other one, do these two to 100 psi, and we're going to throttle each one just like we did before, and then tape and mark them, and then we'll come back in about an hour and see if it has leaked at all, and then we'll let you guys see it, and then we can figure out what part has leaked, and we'll talk about, okay, now if this part has leaked, how could we fix it or go even farther to fix it? And just crack it just a little bit, especially the hot gas loop is going to be really, really fast. Because it's just a pipe up and back. I mean, it's only about 8 feet of pipe, maybe 10 feet of pipe. Okay, it don't be right at 100 because we're going to mark it. So go do the other side.
Yeah.
That was me. I put that hose on and it leaked. I didn't tighten it all the way.
You want to keep that in the recording?
Yes, I will. It's all right. As long as I point out all your mistakes on the recording, we're even, right? Because that'll be a whole nother class. Now, these hoses have to be in good condition because when you're pressure testing,
It's coming out of here.
oh, so it's not my hose, it's your braze joint. So guys, guess what? He's got to fix that because he's got a leak on that. And that was copper to copper. That should have been real easy. I'm going to go ahead and fix that real quick for you. Now stop. What didn't I do that I should have done before I fixed that?
There might be gas still on the line. Should have.
Nah, it leaked out. That hole was pretty big. I didn't take the core out of the valve, which is okay. We're going to leave the hose on, so it doesn't matter if the core is damaged. I mean, it would matter if we left that valve on the system and that core would leak because I added that heat, and I showed you guys earlier that there's rubber and plastic or nylon inside those valves, and they can get damaged from the heat. I didn't hold it on there that long, so it got hot, but I don't think I damaged the valve. But we're going to put the hose on here. It's only when the hose is off that I got to worry about the core leaking, so I'm not really worried about that. I don't really even need the core here when I'm connecting the hose. Remember, all I'm doing is pressurizing it to find the leak. Now, you do have to make sure when you connect these hoses that inside of here is a rubber seal, and you want to make sure that the rubber seal inside your hoses are good, because you're going to leave that hose on the system, and if your rubber seal on your hose is damaged, it'll drop pressure too, and it's not that the machine has a leak, it could be that the hose was leaking. So go ahead and reconnect that. Be careful, the valve may be hot, so grab the valve itself with pliers while you tighten up the hose, okay? Grab the nut. Grab the nut with pliers. There you go. All right. All right, so you're going to put tape on all three of these. These are going to be closed, and by them being closed, it should not drop pressure. We'll come back a little bit later. We'll look at all three of those gauges to see if any of them leaked at all. Run your tape the other way, which is a little bit easier. Run your tape this way. It's a little bit easier to identify, like if I put a line there, if it moved or not. Okay? Try to get right even with them, because if you look at an angle, it might look like it's leaking, you know? So again, this is a little bit difficult if you're going to be working in a customer's house. You wouldn't do this all the time. And someone asked earlier, like, is this refrigerator even worth all this work? No, it's not that this particular refrigerator is worth all the work, but here's two things. One, if you're doing warranty work for the manufacturer, and this hot gas loop was bad inside the refrigerator, a lot of times the manufacturer will say, well, that loop's not repairable. We're going to authorize a replacement to the customer. But the technician, in order for you to get an approval for a replacement or exchange, is that their technical support people have to approve that. And they're going to ask you as a technician, how do you know it's the loop inside the wall that's bad and it's not this condenser that's outside? Well, I isolated all the components, and that's the one that leaked. So the problem is the pipe in the wall, and it can't be fixed. And they're going to say, okay, we'll put it up for review, and we might replace it for the customer. The other reason why you might want to do something like this is some of those refrigerators in the class, that's a $14,000 refrigerator over there. And I told you that there's that wire that we can put through the hot gas loop if it was leaking. And in the last video, I actually put a picture of the kit on the video so you could see it. But again, a $14,000 refrigerator, I can replace every one of these components and spend all day doing a sealed system job on that one fridge, but I could charge $4 grand to repair it, $1,000 in parts and $3,000 in labor. Would you guys want to work one day, 8-hour day for $3,000? So in an instance, sometimes a repair like this is warranted. It's worth doing. On this one, I probably wouldn't do this, but it is the same process when I'm working on a $400 fridge or a $4,000 or $15,000 fridge. I still have to learn to identify the high side and the low side to determine what part's leaking. Because nothing more you want to do is go in someone's house, see that the unit's leaking, and then say, oh, I think it's the condenser, order a condenser, replace the condenser. And this is not that hard. It just screws on and then 2 pipes and we're done. But the point is what if you went ahead and replaced this condenser, charged the customer $500 for the job or whatever it is, and then the customer calls you back 3 days later and says it's not cooling and it leaked out and it wasn't the condenser. So how do you identify what part is leaking and how you would go about fixing it? All right, so now we've marked each one. The gauges are closed. So even though it's connected to the tank, I have it disconnected from the tank so that these valves, now one of these is going to drop. They have to. We don't know which one yet, but we're going to come back towards the end of the class real quick, maybe the next 45 minutes. We'll come back and take a look at this and determine what part of this is leaking. Okay?